Hi, everyone. Does this work? If I speak into it? No?
Yeah.
Oh, it does? Can't hear me? I'll try to project. So thanks for coming out. We have some great talks lined up, webhooks and serverless functions, which I personally am really excited about. As you guys know, this is the Tampa Devs meetup. And if you didn't know, may the 4th be with you for all of my Star Wars fans out there. Yeah, I don't know if my boss is listening, but he actually made this slide, so obviously he's a Star Wars fan. Our agenda for tonight, we're going to thank our sponsor. We've got an icebreaker game. We'll do a recap of who we are, look at what we've got coming up in the future, talk about ways that if you wanted to support or get more involved with our community, you can do that. And then we've got our talks. So first things first, we want to say a big thank you to ReliaQuest for sponsoring. Obviously, we're here at their location tonight. They also generously sponsored the food. I would just want to point out that they are one of the fastest growing companies, and they also have won several awards for being best place to work. They're a cybersecurity firm, and they have a number of different solutions that range from cloud security to phishing, ransomware. So if this type of thing interests you, make sure to go to their website because they are hiring. I know they've got some open positions at their Tampa locations. Big shout out to them. Thank you for sponsoring. And then we're also always looking for new sponsors for what I just said, which is going to be locations, food, events. If your company might be interested in that, please connect us because we're always looking for new sponsors and looking to grow the community, and new sponsors is one way to do that. So now on to our icebreaker. If I can remember where it is. Can I open your Slack on here? Oh wait, just kidding, right here. So it's, you go to your phone and then you go to this website, quicz.org. And then you enter the code, the 895742. Again, that is quicks with a z.org, and then the code is 895742. Nice. I think that Vince said he wants to give out a hat to whoever wins the game. So there's a little bit of competition. Vince is also modeling the hat back there. So if you're interested in a hat, bring your A game. You get points for not only getting it right, but also for being the first to answer. So keep that in mind. Speed is important. And to give you guys a little bit of a hint, I think the theme of the quiz tonight is accessibility in web, for the quiz specifically. All right, let's get started. Question number 1, an accessible IT system is one that can be operated in a variety of ways and does not rely on a single sense or ability of the user. True or false? True. Is that too fast? I think it was set at 15. I think the other questions are also not as long as this one, so I'll adjust the time if I need to. But who do I have? Who's 150 cowboy hat? Creative, I like it. According to World Health Organization, how many people live with a disability? 0.5%, 5%, 15%, or 25%? Do I need to up the time, or is this okay? Okay, I think the rest of the questions are shorter. The correct answer was 15%, and again, this is in the context of people who are accessing a website and what type of accessible methods they might need. Cowboy hat, 251. Oh, it's just the cowboy hat. 251's your score. I got it. Next question. Clicking the logo on a website takes you to the front page of the site. Should that be a button or an anchor tag? Again, it takes you to the front page of the site. Is it a button or an anchor? Anchor tag. Cowboy hat, killing it. The user has increased text size in the browser. However, not all of the text is increasing proportionately. Why would the text in the table still be small? Font size is set with pixels. That is one reason that the text might be small, and instead you would want to use something like REM or EM, which is going to be a proportionate size. Who is this? I just got to know. Nobody's going to tell me? Okay. ARIA role values are case sensitive. True or false? If you look in the ARIA spec, it does say something very specific about this. True. They are case sensitive. Okay, Leslie. Is this valid HTML? We have a nav element with some list elements inside of it. Is this valid or invalid? No, a list element has to be used inside of an element that has the role list. So that might be an unordered list or an ordered list, or it could be like a div that you have explicitly assigned the role list to. Leanne, nice. What is the implicit role of the section element? Area, region, section, or content? Region. Phil, we're just jumping all over the place. I like this competition. Which role requires the following attributes? ARIA value min, ARIA value max, and ARIA value now. Would that be a date, text, radio, or a slider? I believe in you. Slider, nice. Oh, I thought that was it. We have more? Oh, we got one more. Oh no, that was it. Leanne, hat? Leanne won a hat. Leanne, I don't know. Okay, there. Yes, hat winner.
Well, we got a hat. I got shirts. What do you want? Yes. We'll just here, come up.
It's like all of the above.
Here. Okay.
Way to go, Leanne. Okay. So for just to kind of state it, although I think it's like fairly obvious, we like developers. We think the developers are great people. So part of our mission is creating a community where developers can get together with other developers and we can learn and grow from each other. And we hope that that rings true with every event that we do. T-shirts and stickers. T-shirts are $20 as modeled by Vince, and I believe stickers are sitting on the front table, I think, if you wanted one for your laptop or whatever. Next events. Did you want to talk about the next events, Vince?
Yeah. Yeah, I'll talk for the next events. All right, can you guys hear me? So for our next events, we're not doing a tech event next month. We're just taking a break from that. But we are doing a meet and greet 2 weeks from now. I don't know if you guys went to our last meet and greet at Armature Works where we had like 100+ people, and security got mad at me particularly. Yeah, because we're blocking up the lanes and they're like, it was a hazard. Anyways, we're doing it on the lawn this time, so we don't have to worry about all the security issues. It's also in conjunction with the 20s and 30s group in town, so it should be a pretty good turnout in case you want to like hang out and chill and get a beer. No agenda that day, so that's 2 weeks on May 18th. And then the next event we're having after that is another networking event, but this time it's through ReliaQuest. So ReliaQuest is actually sponsoring a bowling event where they're paying for both the food and the bowling. So you just come there hungry, and you go and meet some people from ReliaQuest and like other developers, and you just bowl and have fun. Literally all paid for. So you can invite other people too. Like if you want to invite a +1, make it a date or whatever. So yeah, so that's on June 22nd. Yeah, we have like 75 people like tops that we can have at that event, but I'm sure like anything over that's okay. So yeah, free food and bowling, can't go wrong with that. And then our next big tech event is going to be in July. This is through PwC. This one will be really big because this is also like PwC's like employee get together too. So if you ever want a job at PwC or want to meet people at PwC, this is probably the best place to do it. So lots of networking opportunities, and there's going to be beer and free food as well. So, and it's actually it's on. If you guys know anything about IoT, it's a really interesting topic. So like how to automate stuff at home, and with hardware and Raspberry Pis and other stuff. So yeah, that's going to be a really cool event. That's 2 months from now. That's our next tech event. The other ones are going to be like just regular general events. And then we're also hosting a hackathon at the end of the or on October. So this one is going to have a $20,000 prize pool. It's through one of my hackathon organizing friends. And we're just establishing like a venue in Tampa. So I'm going to partner with like USF as well as anyone else that wants to get involved with that. And we've had some people compete here before, like Jonah. What's up, Jonah? Yeah, Jonah and I competed before, and we like won like a couple grand. So like, what I tell people is like, you just come here and you're probably gonna make money, whether it's like $200 or $300. Yeah, just think of it as like a side gig. You're gonna come home. You're gonna come there. You're gonna like get some free food, learn something new about telecommunications, probably win at least $200, and then go home happy. So yeah, it's really awesome. We got like big sponsors here with like telecommunication APIs. So think of like Verizon Wireless, or like think of like other big firms like Twilio, but like the lesser known variants of them, you know, that are trying to brand themselves. So we're having that, and we're also looking for new speakers as well. I think yeah, like we're always looking for new speakers. Like if you're interested in talking, I'll make you look good on social media. So in case you want to update your LinkedIn or whatever, you know, and like put it out that you're a speaker now, such developer, a speaker and developer, and market yourself that way. Yeah, I'll do all the photo, all the social media for you. And then yeah, I'll get you one. All right, and then our social media, so it's at Tampa Devs, at Twitter, LinkedIn, Instagram, Meetup, and then we have a Slack as well, and then tampadevs.com, and then our email. So yeah, I'll go ahead and give it over to Chris. All right. All right. Let me swap this out. Here you go.
Make sure you mute too.
Oh, okay. Yeah, I need to mute myself.
Hey, can you guys hear me? Can you hear me? Yeah. Think so. Let me just make sure I see in the chat. Hey, can somebody just send a message in chat if you can hear me?
Oh, let me check.
say something again?
Hello. Yeah, you can. All right. Cool. All right. So webhooks. I'm Chris Packett. Hello. All right. So when I was trying to think about what I wanted to talk about today, I thought, what's the thing that I can talk about in its entirety in a 45-minute talk? So I picked webhooks. The way that I like to conceptualize technology a lot of the time is through this paradigm, connect, process, store. I feel like you can kind of compartmentalize a lot into that. If you can think of something else that's outside of that category, then it's probably an edge technology or something like that that's not maybe on the web or something that doesn't connect to the internet. But throughout this talk, I'm going to focus on these first two, because webhooks are primarily on those first two. So we have this situation where we have some system A and a system B, and system B has some source of truth. And you can think of system A as, if you work at a company, this might be the technology that you build, and then system B being like a third-party technology. So in today's talk, I'm going to do some live coding, and we're going to use Stripe because Stripe has amazing webhooks. If you know anything about webhooks, you know that Stripe's the de facto standard. So you want to get data from system B. So, and you may even want to sync it, right? So you may want to push data to system B. You want to get data from system B and keep those in constant sync. Now, how do you make that exchange of information, that exchange of data, reliable and secure? That's what this talk is about. So you think about how to get data from one place to another. There's a few methods, and it's not a fully comprehensive list, but it does, I think, a pretty good job. So you start at the very left, and you have manual data entry. I'm actually going to talk about each one of these in the slides to come, so I'm just going to leave it there for a second. Look at it. Cool. So any Harry Potter fans here? Yeah, great. Pick the right audience. Great. So manual data entry. Hopefully none of you have ever had to do this. It's soul sucking. But then as technology progressed, we started to come up with better ways to transfer data between systems, right? So we came up with this amazing piece of technology. It's probably the best piece of technology out there. Does anybody disagree on that?
Amazing.
And then, RPA, web scraping. So instead of having people do this, you have machines do this. And it's not automated in the sense that everything's behind the scenes, but it's something you can set up and kind of, it acts like a human on a computer, right? Then you have short polling. Anybody familiar with short polling, long polling, these kinds of things? So short polling is basically sending requests, that could be HTTP requests, for instance, to the system in a very deterministic interval, right? So an interval that's constant. And system B might not have the information that you need when you ask it. So you keep asking it over time, and eventually Hedwig here will deliver your message to your service, right? Long polling, on the other hand, is a non-deterministic interval. It's basically making a call to that service and then waiting until you get the message, right? And message is actually something that you'll hear quite often.
I don't think you shared your screen.
Oh. Is that good?
Yeah.
Cool. How do I go from the same slide? Slideshow. Cool. So message is a term you'll hear a lot in webhooks, event-based systems, asynchronous systems. So keep that in mind. Webhooks are basically, instead of you starting that request, the system B sends you the request. So you never have to like spend your own resources, if you want to think about it that way. You don't have to spend your own resources trying to get the information. When they send it to you, then you just use the resources that you have at that moment. So does that make sense? Okay, cool. So there are a few concerns with webhooks. There's reliability concerns and security concerns. So reliability concerns, events sometimes don't send at all. That's a problem. Events sometimes are duplicated, so you might get the same event twice, 3 times, 4 times. Events send, but you can't process them. So let's say your service, your system A, for instance, is down. Maybe when Stripe hits your endpoint, it returns a 500 or a 400. So that's a concern. And then events are sent in an unexpected order. So with Stripe, when a payment's processed, you have charges, you have payment intents, you have all these different domain entities that are going to send, and they could be in different orders. There's also security concerns. So of course, if you open up an endpoint to the public world because Stripe needs you to expose that to the public world, you might get events sent by bad actors. That's a problem, right? And then insecure connections. So if your data is not encrypted when you make it, especially with Stripe, where it's payment-related information, you don't want that to be received on a non-HTTPS port. So those are concerns. How do we address those? So for the first one, there's this concept of change data capture and event backfilling. I'm not going to go into that too much because it's kind of out of the scope of the conversation or the talk. But essentially what it is if you don't get a request, you're kind of going to do the short polling method, where you make a request to an events API or a CDC API, that's what they call it, to get whatever events have occurred since some point in time. I'm not going to go too much further into that because I just think it'll take quite a bit of time to unpack it. Events are duplicated. So there's this concept called idempotency. And it's basically making sure that whenever a request is sent, that you can process that multiple times if need be. So for instance, let's say Stripe sends us a webhook with order details. And on that order, there's line items. And those line items have state, right? Like amount and status and that kind of thing. Well, when you get that request, you probably don't want to use that state, because if you use that state, then what happens if you get events out of order? Or what happens if you get duplicate events? Over time, you can see how your state from that JSON payload or whatever could get out of sync pretty quickly. So what you should do instead, and to make your endpoint idempotent, is to use the order ID on the request. So every time a webhook request comes in, you look at the order ID, you make a request out to Stripe, get the latest order details, and then use that to update your system. That way, if something's duplicated or if something is sent out of order, you're always looking at what's latest. So that's that. Events don't send 500, 400. There's retry logic in place on the Stripe side, and you can also set retry logic on your own side. Just depends on the webhook system you're working with. Luckily with Stripe, they're just so good that you really don't have to do much. They do a lot of it for you. Security, sent by a bad actor. So this is something where you can set up signature verification. We'll get into that a little bit. I'm going to do some live coding. I'm going to try to build a webhook event processor in 30 minutes. So we'll see. And then you just want to make sure your endpoints are HTTPS or TLS or whatever the term is there. So let's go. Does that make sense? We're ready to go into coding? All right, cool. Cool. So I'm going to start from scratch because why not? So let's create a. Can everybody see that?
Yeah, you can make the font blow up a little bigger.
How's that? Better?
All right. Bigger, yeah. Some of us are getting old,
All right. How's that? Okay. Cool. What do we want to call it? Bonsai. I like that.
Harry Potter.
What is it?
Harry Potter.
Harry Potter?
Yeah.
Harry Potter bonsai tree. I like it. How do you spell bonsai? That? So let's go. We're going to do it in Node because I don't want to have to compile something. So let's go. All right. So let's use Express. Express is easy. So we need to npm. This is too small. All right. Okay, so npm install. I'm going to install .env as well, so we can have environment variables. Okay, going to create a source folder, create a server. Press. IntelliSense is bad today. Doesn't give me what I want there. That's fine. So we're going to want a .env. By the way, anybody who has questions, please just shout it or raise your hand. I should be able to see it. Our server is going to need a port. I like 7,000. No, I don't. 4242. Let's go ahead and load that in. So if okay, if we don't have that defined, we should exit because we can't do anything without a port, right? So then let's create an Express server. So Express, or I guess it's app. So that's colloquial or idiomatic. We're going to create a router. I think it's app.router. What is it? Or I guess it's express.router. Okay, and then app.listen on port. Okay, we're going to listen to it on ports 4242. All right. Now we got to build it. So I'm going to use Webpack, and it's kind of overkill, but I use it by default. So I don't remember how to do this. Module.exports equals. Is that what it said? Yeah. All right. So mode. I really shouldn't be doing this from scratch. This is bad. Did write some notes here too. Entry point. So we're going to have a server entry point, which is going to be at /source/server.js. We're going to have an output. You'll see why I'm doing this later. We're going to have, yeah, actually, they're not going to be able to hear me if I go over there. I was going to write down what we're going to do, but it's fine. Basically, we're going to create a web server.
I'll bring it over.
That would be great.
Okay,
Yeah.
I got it.
Yeah. I saw one in there. All right, cool. Thanks. So, yeah. So we're going to create a web server right here. Web. This is going to receive the requests from Stripe. And the first iteration of this project, we're going to accept the request from Stripe, and we're going to process some process. So this process, I'm just going to make it arbitrarily 5 seconds long. It's going to be something that runs in the background that we don't take some time, take some CPU resources, right? So it takes 5 seconds. And then once it's done with that, because there's nothing to kind of send this off to, we have to process this synchronously before we can actually send a request back to Stripe. So Stripe is going to expect us to send back a 200 status code, else it's going to try to retry. It's going to retry the request again. So 400, 500, etc. But you know, you can see how this can become pretty unscalable, right? Like if we get like 1 request per minute, then this is not a problem. But if we have a big company where we have a lot of customers and we have lots of payments because we're getting a lot of money, then this isn't going to work very well, especially if you don't want to build like a crazy infrastructure. So what do? We're going to create another process, basically, that we can pass these as jobs to into worker services. Okay, so I'm just going to create 3 of them here. Worker, worker, worker. And what it's going to do is when a request comes in, it's going to pass a job to each worker. And the goal is to send a request back to Stripe as quickly as possible, because Stripe keeps an internal whitelist and an internal blacklist. And a lot of companies that use webhooks or that produce webhooks do that. Otherwise, their infrastructure would just get pummeled. Like if they didn't keep a whitelist and a blacklist, then you know they would be sending so many requests to APIs that don't deserve it, basically. So the goal is when it comes in, it goes out immediately, and you just take it from there. And that's where your own retry logic comes in. So a little bit ambitious, I guess, for the remaining 20 minutes that I have, but let's try it. So we want the output to be, this one I'm going to read notes for because I don't remember how to do this. That doesn't look right. Path.resolve. Your name and then /build. We want it to go to a build folder. And then we want the file name to be name.js. So basically, whatever name is here is going to be on the name in the output, right? So if we build a server, it's going to be server.js. Worker, it's going to be worker.js. Okay, and then this one's like this. I think that's everything we need. So what I'm going to do is run Webpack. So Webpack. It's going to ask us to install Webpack. Waiting for things to build. It's the name of the game. All right. First error. Love it. All right, guys, I'm going to cheat because why do we need Webpack? Because we're going to create another process and we need multiple entry points. So you'll see in a sec. It's That's it. I think this might be also the thing. Yeah. Boom. All right. Cool. So let's run it. I'm going to install Nodemon. Nodemon is a service that helps you run a dev server. So npm install. Nodemon /source/server. Oh yeah, I got to add it to the package JSON. So let's create a script. Call it dev. And then nodemon /source server JS. And then npm run dev. Cannot use import statement.
Type here in package JSON.
Huh?
Because you use import, you need to type here. Yes.
Oh, here? Module?
Yeah.
Thank you. Nice. All right, cool. So we got a server. So now let's go to Stripe. And Stripe has this awesome feature. So usually when you have a webhook, again, you need to expose that to the public internet. But Stripe has built something called local events. And local events is a CLI tool that you can run in your terminal that basically builds that gateway for you. So let's just go ahead and copy this. Click tab. Right. Sounds right. Stripe never lies. Okay, next step is to listen. Look at that. They're using events to know that. That's so cool. So then, I don't know how they know that. It's interesting. We're creating a server. And you'll see that it gives us a signing secret. We're going to use this in a second. I'm going to copy it and add it to our .env. Stripe signing secret. Okay, keep that there. Probably have to restart server. And then we can start triggering events. So to do that, I need to create an endpoint. So let's go to server.js and router.post. And I think, yeah, they actually built some of this already. Let's just copy that. Router.post webhook. Close that up. Close that. Okay. And then let's go ahead and add this to the middleware. This is how you do it. Okay, let me restart this. Bless you. Okay, so trigger events. Actually, they do it for you. We're just going to do this. We're going to copy it because there's no reason to recreate the wheel, even though that's what I've spent the last 20 minutes doing. So what are we doing here? We're getting the signature that Stripe sends us. So a signature is basically going to be something that is different every time they send a request. This is how they calculate a signature. they take a secret, the one that we just got, and they take the payload, the body of the request that they just sent us, and they encrypt the body with that secret, and out comes a signature. Does that make sense? Okay. So they're sending us a signature. They've already pre-calculated it. And we're just going to use Stripe's node package because they already do this for you. So let's go ahead and all this. How's my time? All right, let's go ahead and import Stripe. How did they do it? Okay, import Stripe from Stripe. Okay. So stripe.webhooks.construct event. So this is basically verifying verifying the request. And then this needs to be process.end. That. Okay, so now let's just do this. Let's just console.log json.stringify event to person formatting. And then I'm actually going to put that in here and then just do the payment intent. And then we're sending, this is one of the most important parts for Stripe, to send a request back as a 200. So let's go ahead and run this. Okay, and then let's go ahead and copy this command, go back to the terminal, open a new tab, and then paste. Trigger succeeded. We'll see that that came in. It shows that we responded with a 200, and then let's check the console. It looks like it posted the payment intent. So cool. Let's break it. So let's create a new file called stress.sh. We're going to create a shell script that's going to run what I just ran in an infinite loop. Does anybody remember the bash header? We don't have the guy from last week or last. Awesome. I'm just going to follow the Google it thing. Bin bash. I think you're right. Yeah, you're right. Okay, while true, do, where is it? It's hidden. Oh, I should do this. Okay, that, done. I love bash. It's just so, do it. All right, so let's go to a new tab and then start /stress.sh. I think it's 700, right? Sorry, I had to. All right, so it looks like it's running. This is different every time. Oh wait, yeah, okay, it's running. So that's just gonna run forever. Unfortunate part about Stripe CLI is you can't run it quietly. So like, this is as fast as it's gonna go in this shell. So I'm gonna have to create like probably 10 shells and just run them all so that we can get like 50 requests a minute or something, which is super lame, but it's okay. So now, let's create a test of sorts for performance of this web server. So I'm going to create a variable called remaining requests. And I'm going to create another one called total requests. And then every time that we get a request, I'm going to increment it just going to put it in here. I'm going to get rid of this, increment this by 1, and then increment total requests by 1. And then what I'm going to do is console.log remaining. All right, let's put it at the beginning. Remaining requests left. Console.log total requests total. And then because it's going to get kind of, I like to put date stamps on things or timestamps on things just so we can see how the timing looks. So let's add another one. Okay, let's see how this works. Oh, we didn't set up decrement logic. So we have to do some processing, 5 seconds. So I'm going to create a sleeper timer or sleep timer thing. And then after that's done, we're going to decrement the counter, and then it's going to return the 200, right? So await. So this needs to be async. So hard working with at this Zoom. Await. Don't worry, I didn't memorize this. I did this last night, so it's like fresh, but resolve after 5,000 milliseconds. And then we're going to decrement this by 1. So now, let's see what happens. So you'll see at this slow of a frequency, it's kind of able to keep up. You can see it's at 2 left right now, and it's going to probably stay there because it's going so slow. So what we're going to do is add a couple more. One more. Let's see how we're holding up now. 6 left, 7 left. You'll see it's not going to keep up, right? It's going to go higher over time. So let's stop this. This is a problem because now your web server is tied up. Your resource spend is probably going up, and your customers aren't getting served as fast, XYZ, whatever you want to say is the bad thing there. So that's where this comes in, workers. Any questions? Is this all making sense? Okay, I'm not just talking head. All right, cool. So let's create a worker JS. I stole this from Heroku. Heroku has a pretty good model for how to do this. So we're going to use node concurrency. I don't really know much about it, honestly, but I know how to write some simple code in here, and it just works, so I'm just going to do it. We're going to need to install some packages. So npm install throng, bull, IO Redis. That's it. So throng is for concurrency, bull is for creating worker jobs or worker queues. IO Redis is the mechanism, or is the storage place where we put the jobs that bull will process. That doesn't make sense, don't worry. Okay, so we're going to import throng. And then throng takes 2 arguments, or it takes an object with 2 arguments. The first argument that we're going to pass in is the number of workers. So how many workers do you want? We're going to do 3. You can actually, when you deploy this on infrastructure, you can create different servers for each worker if you want to do it that way. But we only have one computer here, so it's gonna, I think it uses virtualization, but I don't know. So we're gonna create a constant max workers, or number of workers, I guess. Number of workers equals 3. And then the second argument is a function that gets run for each of the workers, kind of like a bootstrapping function. So I'm going to call it start. We're too modern for that. So what's the start function going to do? It's going to start a queue. So each worker is going to have a queue that you can put jobs into. So whenever a Stripe webhook comes in, we're going to just pass it along, and then it's going to do that asynchronously. So we're going to need to create a queue, which means that I'm going to need to create a new file. So we're going to need I'm not going to write this. Full queue. All right. How do I get started? Here we go. So we need to give it a name. So let's create a new queue called Stripe Webhook Handler Queue. And this is going to be a new queue. And the first argument is the name of the queue. Doesn't really matter for this, but I'm just going to add it. And then the second one is the Redis instance. So let's import Redis. We're going to create new Redis. And then this is going to take the URL for the Redis server. So I got to start a Redis server. Done. I love Redis. And it's running at port 6379. So let's go ahead and add an environment variable for that. Redis URL equals Redis. Oh, no, it's colon. What was it? 6379. All right. So then we're going to cool. I think that's all we need. And I'm going to export this. And then in the worker, I'm going to write a process function. So a process function is going to run on every job that you pass it. So that's going to be no IntelliSense. It's fine. That's it. So this is going to be this is the first argument to this is the number of jobs that you want each worker to process concurrently if you want to. We're just going to make that 3. And then it's going to take a function that's async. It takes a job and then processes it. So what we're going to do is we're going to await. We're going to do the same logic as we're doing in the in the server. Okay. This is going to basically be the same exact logic, but it's just going to be working in this piece of the code instead of this piece of the code. So that's pretty much all we need for that. The only other thing I need to do now is just import that to this file. And then add it to the queue. So instead of running this logic, this is the old logic, we're going to run the new logic, which is basically just .add empty job. We don't need anything parameters wise. And then it should pass this off to that and then immediately return 200. I'm almost done. But first, we need to actually build this worker. So let's go to Webpack, add another entry point, and then everything else should work out of the box. So let's save that. Let's go ahead and do npx Webpack. Actually, we already did this. npm run dev. It's going to fail. Config for. Oh, I see. Got it. Yeah, I think we need to.
If you want to read .env, so I suppose import config like open server.
Okay, that's right. Like that. For time purposes, I'm going to just copy what I have in this one. I did something different here. I'm just copying it. Did I copy the whole thing? No. One more file, create Redis client. Oh, I remember. Okay, so we need to go to Webpack. Oh, I'm not running the worker process. So it's trying to add a job to a worker that doesn't exist. So I'm going to create. I'm adding a package called concurrently, which basically is used in NPM packages to process commands concurrently. So what I'm going to do first is build the code into the build folder, and then nodemon both the server.js and the worker.js.
So it's like one process is putting the jobs into Redis database, and then the workers are getting it from the Redis database, putting it into their own queue, and
Right. So yeah, when it's put into Redis, that fires an event that the worker is listening to, and then the worker sees that and then takes that job data and then processes it. So the only communication between the two processes is through Redis. So you can't define a global variable and then reference that global variable from different processes. You have to communicate through some channel that it understands. So that's taking a while, but I'm going to run concurrently -p names -n. So we're going to build the server first, and then we're going to run the server, and then we're going to run the worker. Cool. I edited it while it was changing it. So let me copy. I gotta make this smaller for this. Work. We're almost there. Oh. Anybody see it? I'm going fast, I'm sorry. This is how live coding works. I told my wife that I was gonna not do the demo from start to finish, and that I was gonna basically create branches in Git, and each branch would be a workable thing. And then at the end, I'd be like, all right, we're just checking out to the last branch. And then we would just use it. And I was like, you know what? That's boring. Not doing that. It's like, I didn't get a sweat. I didn't get a sweat today, so might as well get it now. What to do? I know what we can do. Is it? Oh. Here, let's close all these, make sure that nothing's unsaved. All right, what's the error? Cannot find module source queues. It's right there. QUs. Huh? Oh, maybe. I think this is a different name. Yeah, that was exactly it. So the name of the queue is different. Boom. And then this one needs the same treatment. All right, this must work. Must. Let's use our developer brains. Come on. This seems wrong. Let me see what I had on that one. was the file? Worker? That might be it. If there is no time left, then I can just explain what it does. I'm giving up. I can't do that.
Yeah, I guess we can explain through like how it works, and then Jackson can do the second talk, and then if we figure it out, we can go back.
Okay, cool. Yeah, let's do that. So let's try this, actually. Does anybody want to volunteer to try to explain what they think this will do? Or what problem it's solving based on what I had said earlier?
Question.
Yeah.
Why it's better one alternative of just WebSocket? So if you don't want a long or short pool, so just make WebSocket so it's wait when it's answered.
So the only thing about webhooks or web sockets, from my experience, is that if you don't own the third party, you can't set up the other end unless they support it. Stripe doesn't support web sockets in the way that you're talking about for getting events like that. They do on the front end. So I think WebSockets using the Stripe UI package when you're building like React apps and stuff, I think it does have WebSocket capabilities there, but it doesn't have it on the server side.
Kind of alluded to this in terms of webhooks.
Yeah.
What's the point of creating a webhook when you just call it a straight API directly? Is it mostly just for IDM potency as well as just for retries?
It's mostly for, so there's a couple benefits. Number one benefit is it keeps your resource utilization lower on the infrastructure side because you don't need to short poll or you don't need to long poll if you need to keep that constant synchronization with that service. So webhooks is just a way to only get events when you need them or when data is available for you to act on, as opposed to checking every so often. And then the second big benefit of webhooks is that it's something that you can, like basically, I lost it. I don't know. Yeah, I don't remember.
I mean, it's like a push notification service.
Right.
So you're not having to hold it, and whenever some state changes on their side, they notify you of their state change.
Right.
Rather than you having to inquire from them to find out when their state changes. So that's the benefit of it.
Right.
How is it?
I was gonna say, maybe oh, sorry, I thought you were putting on me. I was gonna say
It armed several times, so like, yeah.
at the other line too, maybe designing that JS might fix it, but
Oh, cool.
I was just saying, like, from your diagrams about short pulling, long pulling, and then WebSockets, it just looked like it was reversed. Instead of you pulling them, they're pulling you.
Right.
Is that
Well, they're not pulling you because Stripe and other webhook producers have an event-driven architecture. So for instance, like when you create an order in the Stripe UI, or if somebody creates an order from the Stripe API, they have their own system internally to send events to something. Usually it's like Kafka or some service like that. And then they have their own microservice that handles basically taking those events that happen internally in this core system and then passing those along to whoever has subscribed to them. Does that make sense?
It makes sense. I see. I feel like
The word
on an
polling?
application, you can have the same setup and on an event, reach out to another application and wait for their response.
Mhm.
But yeah.
Yeah.
I think one of the important things about webhooks is when somebody sends a webhook out, they're not expecting you to do any processing, right? So you're responsible. Like they're not expecting for you to do anything other than say, "I received your webhook."
Right. You kind of have to with HTTP. Like you have to give a response, and it just happens to be.
So how it looks like from web developer perspective. So I'm from my browser clients. It's push something, and how it looks like. It's pending request, or so I get something new from internet. Did you get my question?
I think so. So what you're saying is, so you're saying from the perspective of like more on the front end side,
Yes.
how does it work
Yeah.
on the back end? Like,
No, so how it works in the backend, you create it in
Right, right.
show us, so but how will I get to this response? So so one answer to my own question. So
Yeah.
I will see like I make some post request and I see it pending in network. So it will just answer me this long later.
Right.
Or somehow else.
I see what you're saying. So you're saying on the front end, if you have this asynchronous process happening, how do you know when that's done?
Yes.
Because I see what you're saying. So usually what will happen is you'll either set up a short polling system on the front end to see if it's done. And one of the great things about Bull queue is that the response gives you the job, which has the status on it. So you can see if it's active or not. So you could create an endpoint for your UI that says, hey, is this job done yet? Hey, is this job done yet? And you could do that, or you could create a WebSocket, and then that two-way connection would be.
Anyways, to website.
Yeah.
Okay.
There's a third class of security consideration.
Okay.
It's important. To
Awesome.
keep in mind when you're implementing services that originate webhooks. So like something that's sending them out, you need to validate the actual destination of the webhook.
So like an IP whitelist or something, or
Well,
origin?
So you want to look at the host name, but you also you need to have some kind of firewall or something in place on the service.
Right.
When the DNS is resolved, like that could be anything at the time it's looked up. But in a lot of architectures, there will be services that listen on like the local loopback or something. You know, your service running on a given host could send requests to 127.01 and like communicate with that.
So it's like a proxy almost? Like you'd set up a proxy?
Well, you don't necessarily need a proxy. I mean, you could implement something that does a really basic level of authentication or a really basic level of sanity checking on hosting out like the destination.
Right.
But you also just want to have some sort of layer of firewall that just prevents it from talking to
The actual internal service.
Because even
Yeah,
stuff like in AWS DBC of like 169.254, 169.254 will spit out like a bunch of metadata about like your AWS instances. And so like I don't know, if you have something where someone can send a request to that through your webhook service and then they can see the debug output.
Is that like is that different, like is it NAT gateway, something that could have that logic in it?
Well, that's something that is more like at the edge of your VPC, like on, to like another boundary. This is something where it's like I'm talking about. It could be sending traffic like to other hosts in the same VPC, but also to things on the very same host.
I see.
You've got other things listed on the local loopback or other ports that should not be accessible.
Right. So I think.
So that would be like under the whole SSRF, like service side request for banner.
Right. And then CSRF would be under that, or is that
CSRF
the same
is
thing?
a client side thing, like in the browser.
Got it.
SSRF is like server side.
Got it. Cool. Any other questions? Yeah.
Is there, apart from what you showed here, at high level, is there any further testing we should do to set up a webhook? Like
Testing.
Basic testing.
Yeah. So stress testing is obviously important. I think security testing, making sure that the signature actually works, is something else. And then I think creating, I don't know if you need, like if it would be unit tests or like integration tests in this situation, but basically making sure that your endpoint is actually idempotent, and that it doesn't create any weird stateful effects that you don't want to happen. If I'm explaining that right, but you want to make sure that what that webhook is there for is what it's intended for. So just setting up basic unit tests and integration tests for the business logic that you're setting it up for. Yeah, those are the main. Anybody else have any other ones? Yeah, that's good. Yeah. I'll wait here to hear the switch out.
Okay. Yeah, let me switch to mic here. Jackson, you want to come?
Sure, I'm here.
I have your presentation.
Cool.
My computer.
So you can just put it here. Donald, everybody want to take like a 5-minute break?
Yeah.
Stand up, stretch your legs while we
Bathroom
move
break.
this technology around.
To mute. That's yours or his?
Yeah. Oh.
Mine's muted. Just.
Oh.
Like, they were always like,
No problem, man. That was a good talk. I
It
didn't.
was stressful at the end, but
That's why I never live good. I never live good for that reason. I've learned that mistake too many times.
It's like, you know, you could
Can you guys see my screen? So I'm screen share. Okay. There you go. Serverless.
Right, you can just go ahead and
Present. There you go. I think everything should be good.
Can we hide this?
Oh yeah. Let me. It just kind of like hides on its own. There you go.
And then we've got this in the center here.
Huh? Oh. There you go. There you go. That should go away. Okay. And let me make sure everything else is.
So I want to move this over. I do not want to stand. Now,
oh, you're just gonna present like that?
for the Zoom people, do I need to speak in the microphone?
Yeah.
Okay, so the Zoom people won't hear me without the microphone.
Yeah.
You can just use the microphone whenever you want.
Okay.
I think I actually have like a what do you I'll do it like this. Do you wanna put, are you just gonna push the?
I'll just push the button.
Okay.
I'm not gonna, like, I'm looking at the like process. There's a whole like XSS sanitizer. So like, there's no point like in retesting stuff. It's like hand it off. So like that's kind of stuff.
How did that happen?
What is your right? But like yeah, I know. I always tell people like this is much.
All right. So does this actually amplify for you guys?
That just goes into the stream.
Okay, so it doesn't do anything to you guys.
But if you're talking to that stream people.
The stream people can hear. Okay. All right. So I think I'd like to go ahead and get started, if that's okay. And in fact, the lady who I was looking for, Stephanie, and we all say thank you to Stephanie. Stephanie got some free food and free beer. So thank you to Stephanie and ReliaQuest. All right. The highlight is good beer, man. So I want to just say thank you also to the whole Tampa Dev group and to Vincent. Vincent, we love you. Putting on these events. I myself, I'm not quite a native to the area. I moved when I was in 3rd grade, but then I was gone for 20 years and now I've been back for a year. And I work from home, right? I'm 100% fully remote. It gets a little lonely. So it's great to have a place where you can come and you can meet people and other people who don't think that you're just talking gibberish. And so thank you, Vincent, for putting that together for us and organizing this. And Lydia as well. I think you're on the board. I don't know exactly what you do, but you give great intros to these meetings. Okay? So who am I? Some crazy guy. So my name is Jackson Atkins, and I'm a senior software engineer at My Advice. We're a company based in Utah, and we do online presence management for doctors and lawyers' offices. And I want to give a particular shout out to my boss, Mr. Brian Burdett, because he has allowed us to explore new types of architecture, the ability to do serverless architecture, which is not what we had, but he was willing to, risk it with us to allow us to explore these new fields. So just shout out to him. And another thing I just like to mention, I know I've talked to a lot of people here and some people are like, hey, I have this kind of background, or I'm trying to get my first coding job, or I didn't maybe go to school for coding. So just as an encouragement to you, I'm 100% self-taught, okay? I didn't go to boot camp or any of that stuff. I just hammered it out, learned it on my own, and now I'm a senior software engineer. So that's just an encouragement to all of you. If that's where you are, you can do it, it can happen. All right? All righty, so I've got a few of these AWS certifications. I just bring those up to say that we use AWS at my workplace. It's the one that I know the most about. We're going to talk about serverless, which is very related to the cloud provider. So I'm going to present this presentation from the standpoint of using AWS because that's what I know, that's what I use. All right, and it's also the biggest one. But if you use Azure or you use Google Cloud, pretty much all of these same services exist there. They just have different names. So you can Google what those names are. All righty, so I want to start out with a story. So one of the first places that the first place that I ever worked, I got a job and I'm supposed to do development work there. And they say, hey, you know what, can you get on the server? Can you update that thing? Because we got a new version of the application. Oh, by the way, since you're a developer, you can go ahead and manage the servers too. Okay, sure, cool, because it's a startup, so you kind of have to do everything. So I log on to this server, and when you log on, it says, hey, this thing hasn't been updated in a really long time. You want to, maybe you should look into that. It's a little more technically written. So I said, all right, yeah, okay, I'll use my hot Linux skills. Sudo app update. Oh man, this stuff is really old. Yeah, okay, sudo app upgrade. All the stuff comes through. You're like, all right, this is awesome. Now I'm a Linux admin. I'm gonna add that to my resume. Okay, but since I just updated this thing, let me just get on the production system and just make sure everything's cool. Sure it is. So go to the site. Everything is not cool. Okay. Production is down. All right. And I'm a new guy there. So I'm back on that server and I'm like, man, what's going on? I can't figure it out. So then I have to call the senior guy. You feel like a dog, with your tail between your legs. Hey, just want to let you know, production server's down. He's like, okay, let me look at it. Right. So he gets on there and he's like, the database isn't running. He's like, you need to restart it. I said, yeah, okay. System CTL, start MongoDB. System CTL status, MongoDB, dead. It won't restart. He's like, let me try it. No, dude, it won't restart. So then we had to call out the big guns. Okay. All right. You've been there, haven't you? You've been there. All right. So you all know what I'm talking about. Well, it turns out that when you update Mongo database and you restart the service, sometimes it puts this temporary sock file, and the only way to restart it is you have to manually delete it. Did you know that? How many people knew that? Raise your show of hands. Anybody? Well, I didn't know that either. But guess what? Now I'm never going to forget. But the point is, I just want to write my code, man. I just want to work on my application. I don't care about temporary sock files or upgrading MongoDB. But there I was. So thankfully, because we're particularly awesome developers, we were only down for like 10 minutes. But we worked it out with our friend Google. So later on, I built a system using Elasticsearch, where we had all these beautiful dashboards, and we got together all of our logs and we aggregated them. And as I was looking through it, I found that we had one server that was getting 5,000 failed SSH login attempts per day. Per day. Like, oh my gosh, man, what's going on with this thing? So we looked at it, we found out whoever had set up the server, who was not me, it was not me. Okay. Really, it wasn't. Whoever it was, that they had not changed the SSH config file to where you couldn't log in with a password. So public IP, botnets decided to just start, hammering this thing because it's returning, hey, you failed to log in. Well, and again, I don't really care about SSH configuration files. I just want to write my code. I just want to work on my application. But hey, guess what? I have to worry about the servers. I have to think about where it's running. I have to think about their security. But that's not really what I want. All right, one other is, let's see here. Also, through my system, I found that this is not actually from the system that I built, but I hope you get the idea. What I found out was our system got used about 3 hours a day because of the type of workflow that we did. All the rest of the time it was basically sitting dead. So I'm sitting here paying for have servers that are big enough to run that 3 hours a day, which means 85% of what I'm paying for is just getting wasted because I don't need those servers for all of those other hours of the day, but I have to have enough for those 3 hours. So I'm just kind of wasting money. So here I am, I'm a developer, I want to work on my application, but what I found myself doing is a lot of administration, a lot of security of the underlying infrastructure, worrying about, provisioning and sizing things because, costs matter. And so how many of you have been where I am? Okay, you've been there, you've been there. Nobody else? Okay, you've been there. A little bit. He manages the people that are there.
I was wondering which part was it, the coding part or I my code, servers.
So what I want to do is I want to be responsible for working on the part that makes my company and what I do add value. I want to focus on our business logic. I want to focus on our application. I don't want to focus on all the stuff that my application runs on, which is kind of incidental. And so that's where serverless computing comes in. That's why it was invented and brought about, is to help people like us, developers, think more about our application and less about servers. Okay? So I thought I would just define what is serverless. So this is how AWS defines it. I think it's pretty simple. Serverless computing allows you to build and run applications and services without thinking about servers. I like that. I'm good with that. But there's a little bit more to it. So let's get into it and see Cloudflare and Azure highlight some other things. So serverless computing, this is from Cloudflare. Serverless computing is a method of providing backend services on an as-used basis. A serverless provider allows users to write and deploy code without the hassle of worrying about the underlying infrastructure. So one of the key things I want you to pick out here, which is why I underlined it, is it says as-used basis. So in serverless computing, the model isn't about paying for capacity, it's paying for use. Okay? And then I thought Azure, because maybe, I think somebody in here is using Azure Cloud. Yeah? Yeah, you're using Azure? So I threw in Microsoft here for you. Serverless computing enables developers to build applications faster by eliminating the need for them to manage infrastructure. With serverless applications, the cloud service provider automatically provisions, scales, and manages the infrastructure required to run the code. So those kinds of problems that I was having, worrying about restarting databases, worrying about patching Linux kernels, worrying about what capacity servers that I'm using, I can hand that over to them. And I can spend more time focusing on what I want to. And in fact, they actually did a survey of 13,000 companies who moved to a serverless model. And they found that the companies that moved to serverless spent 40% more of their time writing codes. They saved 30% on their computing bill, and they were able to deliver their product 3 times faster. Just because they were able to focus on what makes them and their company instead of managing all this infrastructure. So that is the kind of core value proposition of serverless computing. But what I want to bring out to you is that, oh yeah, and how did we get here? So like, where did serverless come from? It's kind of a buzzword these days, right? Okay, yeah, hey, yeah, we're serverless, Where did it come from? So if we look through the evolution of really kind of data, compute, and cloud, it started out, everybody's got their own data center, right? So you're a small company, it's a couple of computers over there in a closet somewhere, or you're a big company, you have a big warehouse, but you actually own the equipment. So you have to have specialists that know, okay, how do I wire all of these things? And okay, I need someone with Cisco administration because I have these, routers so the servers can speak to each other. I have to have a security guard with, badges and all this kind of stuff. So companies were spending a lot of time and money in that. And the first really kind of wave of cloud is when people said, okay, we don't want to manage the physical presence. We're going to go to virtual machines at AWS or Google or whoever owns. So we basically ditched the management of the physical layer. Okay. And we went with virtual machines. So now I just go online and I say, hey, I need a machine that has 4 processors instead of 2, and I click a button, and 30 seconds later I have it. Whereas before, I would have had to go online, or I would have to order one, wait for it to come, then provision it, et cetera, et cetera, et cetera. So then after that, we went from the physical machines to the virtual machines, and then containers came out. So anybody here using Docker? You guys using Docker a little bit? Okay, back in the back. So if you know about containers, they still have like an operating system, but it's really stripped down. So it doesn't have everything that a regular virtual machine would have. It really just has just the basic stuff that you need to run your application. So as a developer, I'm not worried about the whole computer. I'm just worried about a little piece of an environment that can run what my application needs. But still with containers, I still have to update, different kinds of things. Like if I'm running Nginx in the container, I have to make sure it's updated. Or maybe if the newer version of the Linux kernel comes out, I might have to update that on my container. So there's a little bit more maintenance, but there's less. And then the fourth wave is the true serverless. And in a true serverless, all I'm worried about is my code. I'm not worried about the environment that it runs in. I'm not worried about, the kernel that it runs on, or even the operating system that it runs on. I don't worry about any of that. I just worry about my code. I just put my code in there. It runs. So with that, that's kind of how we got to where we are. And that's the evolution of compute towards serverless. And when we talk about serverless, it's important that we think about it not only as compute, like where does my code run, but again, all those other things. I hope I'm not blocking anything, but all those other bits that it takes to run my application. So I'm talking about, yeah, the compute, obviously, but also what about my data? So every time that if I get a big increase in traffic, do I need to provision a larger size database? Or is that also something that can be scaled for me? If I need more storage space because, now people decide to upload videos, do I have to worry about, how many attached devices I have and how much memory they have? So again, it's the compute part, it's the data part, and also these different integration things like API gateway and the queuing services and all of that. So it's all of these components that work together to say, I don't have to worry about the servers that any of this stuff runs on. I don't have to worry about securing, so I have to secure my application that runs on them, but what these things run on, I don't have to secure, I don't have to scale, I don't have to provision, I don't have to even update, it's just done for me. Okay, so that's kind of the promise, but it's more than just thinking about, say, Lambda or putting things in a container. So I thought, all right, with the time that I have, I just quickly go through it. All right, in the compute part, I'm going to go through each one of these layers, okay, and just explain a bit about it to you. So in the compute part, if you want to think about serverless, for AWS at least, we have basically two options. We've got Fargate, and Fargate runs containers, okay? So you've got your application, it's already in a Docker container. The way that you'd normally do it is you would have some set of virtual machines that are out there. In Amazon, we say EC2 instance. And you say, okay, I can run 6 containers on one and I can run 4 containers on the other, but somehow you have to orchestrate that to make sure that you have enough space. So Fargate, and then those machines that it runs on, you have to worry about securing their operating system and all of that. Fargate gets rid of all of that. So on Fargate, I can say, hey, here's my application. I've got that bad boy in a container. And if that container gets more than 80% CPU usage, launch another one. And I always want to have at least 3 running, and the most I ever want to have running are 500. And AWS will just manage that, provision it, scale it. All I provided them was just my container and how much space I wanted to take and when I wanted to scale up or scale down. So not much headache to me. Now, Lambda, okay, so that's basically what Fargate does. Lambda, I don't even have to put it in a container. All I provide is the code itself. So like, for example, Chris wrote a node application. So in that case, he was having to run it. He had it on his computer. He might put it on like an EC2 instance or something like that. He could actually take that, open up the AWS console and type that code into Lambda and run it directly from there without worrying about any of the environment or any of that, just his code. All right. So some of the differences between these are, with the Fargate, you do pay by capacity because you might say, hey, my container needs to have 500 megabytes of RAM and it needs a quarter of a CPU to run. So you will pay for that, but you're going to save money because you can make it really small and then scale them up as you need them and scale them down, as opposed to paying for an entire virtual machine to run it. Also, the Fargate is good if you need something that takes a long time to run, like maybe you have a batch job, it takes a couple of hours, or you have like an application, front end that needs to always be at least something running for it. You can put that on Fargate. And the other great thing is if you want to go on a serverless journey, you can lift and shift. So if you already have your application in containers, you just move it from wherever you're putting your containers now to Fargate, and now it's serverless. Okay? Or if you have a legacy application that's maybe running on an instance somewhere and you want to make it serverless, put it in a container and throw it on Fargate, and you literally don't have to make any changes in the application code. So we did that in our corporation. We had a legacy PHP application. We didn't change any code in the application. We just put it in a Docker container, threw it on Fargate, and now it's a serverless service. Okay? By contrast, Lambda, you pay by usage. So like I have a lot of Lambda functions. I'll talk about one. If it runs for 100 milliseconds, I pay for 100 milliseconds of compute time, whatever the runtime is. And also, but they'll only run for 15 minutes, right? And as I mentioned, this is a lift and shift. You can take what you have, but you're also responsible for the environment because you have a container to worry about. But the Lambda is the code only. I didn't mean to do that. All right, so I'll kind of go through some of these other ones more quickly. As far as the data is concerned, you've probably heard of S3 or used like S3 bucket. So the great thing about S3 is if I have 1 megabyte in my bucket or I have 10 terabytes in my bucket, it doesn't matter to me. I don't have to provision anything. I can add it, I can take it away. Amazon's going to handle all of that for me. I don't even think about it. I just put it on my bucket. Okay. If you want to use SQL database or you want to use a NoSQL, Amazon has some services that you can do with those. It will auto scale based on the number of requests. But again, you're not going to run into a place where you suddenly get a surge of traffic and now your database crashes because you're going to auto scale it. Or you're paying for a big database for that 3 hours that you need that much capacity, but the rest of the time you don't. So you can save money. All right, so that's that data storage layer. And then we got the integration layer. So we think about things like API gateway, SQ, SNS, queue services, event bridge, step functions. Like even talking about your question before, where you said, hey, yeah, you asked a question to Chris about, hey, you know, I need to have the validation of where did it come from, and is there a possibility there could be a leak where, you know, I could inject some code on the machine and then that could return back actually on a local loopback, right? I mean, that's basically the question. So the API gateway actually takes care of that for you. So if you front it with an API gateway, that should not happen.
Well, to an extent, but if you're talking about the WAF functionality built into the API gateway, it's not going to catch it.
It won't catch every case.
And
It does give you some protection compared to what you
it'll
have.
add protection, but it's not like completely, it's not a fancy.
It is not. So I'm agreeing with you. I'm saying there's a bit of protection.
That's a good.
And even like with API gateway, I can do things without using any of my compute power. So for example, like Stripe, and I'll give you an example because I actually have the Stripe set up in serverless. I can set up the API gateway to validate that requests have certain fields or only have certain fields that I'm looking for. And if it doesn't meet that, like say it doesn't have the header for the Stripe signature. If that doesn't exist, the API gateway will just send back a 400 bad request and it never even hits my compute. And it doesn't matter if I get 1 request a minute or 1 million requests a minute. API gateway is going to handle it for me, right? And talking about like your queue service, you were using Redis, right? So you can do a Redis cluster, but you have to manage that. You have to provision it. If you're putting this in, say, like an SQS queue, one request a minute, 1 million requests a minute. Doesn't matter. AWS is going to handle it, right? And they're also going to handle the security of it. I don't have to worry about the security of my Redis cluster. That's their job. I have to think about the security of how my application uses the queue, but I don't have to think about the security of the queue itself. If that makes sense. All right, so same thing with SNS. If you're using an event-based architecture, you can use Event Bridge as opposed to having, I mean, you know, Kafka has a lot of other great, you know, options if you need something like that. But if you basically just need a simple event bus, it's pretty powerful and scalable. You can use Event Bridge and you don't have to worry about the throughput. You don't have to worry about the underlying security of the architecture that it runs on, okay? So having said all of that, are there any questions before I show some patterns? I think you were first.
So what about minus? So all of this, for example, I see some weakness. For example, I have some small application, I don't know, internet shop. So, and if some bad guy decided to DDoS me, so and send many hundred fake requests, I will down, and it's okay. Really, my server will die, so and I'm okay with it. But if I use Amazon Web Services, Amazon Web Services handle everything and charge me after it. So
that is
$100. So and, oh my God, so why? So
So I would say, what you're saying is legitimate, because with these kinds of architectures, if you suddenly got 1 million requests a second, you could do it, but you are going to pay for it.
Yeah, but they don't want.
But you don't want to do that. So
Can I make some limits? So just to say, guys, so if something is bigger than I expect, just stop it.
you can put limits on your AWS account that, like, if you go past a certain amount, it will cut things off. So you can do that, or you can at least get notifications. So something a lot of people will do, like on their own personal account, is, hey, if I spend more than $10 in a month, send me an email. But in your case, you can even put in things that would actually cut the services off for your use case if you're doing this.
Yeah.
Another thing that you can do, which in your use case you wouldn't want to, but you can actually get a service from AWS that's like a DDoS protection, that if that happens, you don't have to pay for it.
Okay.
So that's another option.
Similar question. I'm hearing a lot of reasons to use serverless, but I'm kind of curious of when would you not want to use it? Like, what are
Okay.
the arguments against it?
So some of the arguments against serverless would be depending on your architecture and how you want to implement it. Like if you wanted to use Lambda functions, you would have to refactor your code to do it. So there's going to be development cost for you to make that happen. Okay. So some of the other things is if you are in the situation where you have really highly specialized people that are able to sometimes tune systems like maybe databases or whatnot for your very specific use case, you may not have the same availability to configure those things. Having said that, in most of the shops, or the shops that I've worked in, we don't have anybody who has those skills. And the people that AWS has are actually better at that stuff than us anyways. So we kind of hand that over to them. But those would be some downsides.
So is it safe to say that a serverless solution from AWS is a generic solution where maybe 70% customer base is happy with it, but the people who have specific needs would not be happy with it?
I would put it to you this way. I personally, and maybe because I'm not in the group where I'm like some, MySQL database, genius who can, move the configuration parameters around and get everything tuned perfectly. I'm not one of those people. I haven't found any limitation for me personally for it, but I think that, and I don't know what percentage of customers that would be like that, but it's a concern. And the other thing would be, I think the main reasons you might not want to do it, number one, really, I think, are the costs that it might take to refactor to use those services. And then another argument that you could make against serverless is you're going to have a lot of vendor lock-in, right? Because it's highly dependent on their services and the way that they have configured them. So if you were to say, hey, I want to quit using Lambda and I want to go to, say, Google Functions, it may not be that easy to directly change. Whereas if you decide to move to Google Cloud and you move from everything running on an EC2, which you configure yourself, and you move it over to Google Cloud, it's just another virtual machine, and you just configure it the same as you did. So you could come into vendor lock-in issues, would be another negative.
Honestly, I think it's always a problem.
I mean, it is. And I actually talked with my boss about it before we went on the journey. And I said, hey, if we do this, we could face vendor lock-in. And he said, I'm not worried about it. We've been using AWS for a long time. I'm not planning on changing. So go for it. But those would be negatives. Anyone else?
And also talk about cold starts.
So I don't want to get that deep into it, because that's a good thing to bring up specific with Lambda. So what he's saying is that when you have, say, like a new Lambda function, when you meet the capacity, it may start a second or a third or a fourth or a 10th or a 20th or whatever. And there's a little bit of a delay when a new one starts before it starts serving requests. And there's some ways to get around that if you want to talk about it, but that's what he means by cold start. So that's some of what serverless is like. We saw how Chris made a Stripe webhook processor. So I also built a Stripe webhook processor for our company. And I did it in a serverless framework, and this is what it looks like. So I've got this API gateway. And that's what Stripe sends the webhooks to. As far as security, this thing has whitelisted Stripe's IP addresses, and that's the only place it accepts requests from. So that's a layer of security, but it's not the only layer of security. So what happens is this comes in, and then it also does some basic validation that, hey, this webhook has the Stripe signature header. This webhook has certain fields in the JSON body that I'm expecting. So for example, it will have an event ID that has to be there. And it's not validating at that point that it came from Stripe, but it's at least validating that the fields that have to be there are there, right? And if it doesn't, it'll send back a 400 request before it goes anywhere else into my system. So then what I'm doing is and it also does some transformations to make it processed by my system. It creates the event, and then there's a rule here which says, hey, whenever a Stripe webhook comes in, activate or send that event to this particular Lambda function to be processed. Okay? And so what this Lambda function does is it validates the Stripe webhook signature. Okay? So remember Chris was talking about how there's that signature that they use basically hash the payload, and then you hash it on your side and you compare their hash and your hash. So that's what this Lambda does. And then if it validates that the webhook did come from Stripe, then it goes ahead and puts that in the database. But it uses an event ID, which is unique in Stripe. So if I try to put it in the database and that event has already occurred, this Lambda will just return and it won't do any further processing. So that keeps us from processing the same webhook twice, right? Okay, so some of the ways. But did you see it like in Chris's solution? And one of the things he was bringing up is, hey, what happens if I all of a sudden get a ton of Stripe events, right? Like my processor is going to basically die, right? Which is why you made workers. So in the case of serverless, what would happen is if I don't have enough of these Lambda functions to process all the webhooks that I have coming in, AWS is just going to launch additional instances until I have enough to process them and run this workflow. Okay, so that kind of handles that for you. So then if this Lambda says, hey, yeah, we got this webhook, yeah, it's from Stripe, yeah, it's a new event, it's not one that we've already processed, then it puts an event onto the event bus about the type of event that it was. So it might be like invoice paid or customer.created. There's about 180 of them in Stripe. So, and then the way this bus is set up is that for various event types, there's rules. So let's say we get a webhook from Stripe that through Stripe, a invoice was paid, invoice.paid. Well, this rule is going to say, hey, when an invoice gets paid, send that event over to this Lambda function. And then this Lambda function in our system is going to do things like update our CRM, right? Update some further system. But it's unique to that. Or if a customer is created, okay, I might have a workflow in a stepwise function that I want it to go through. And so this can process as many webhooks as I need without me having to worry about the concurrency, without me having to worry about it. Really, the only code that I wrote is how do I validate the webhook? And then if an event is of a particular type, what do I want to do with it? All the other stuff, the scaling and all that, just the infrastructure itself takes care of it. Okay? Any questions on that?
Do you have to order, or is there like a way to handle like timeout if it's in that timeout?
So if you want to do something that takes more than 15 minutes.
So just make sure that whatever you do is never going to take more than 15 minutes, or or do you ever have to worry about, just in case it does, there's some kind of thing that I have to do?
So what I would tell you is that if you guys are interested in Lambda functions specifically, I can do a deep dive in Lambda functions. I mean, if you are, because I really love them. I'm happy to do it. But quickly to answer your question quickly is there's two things you could do. One would be you would just put that job in a container and run it there, because then you don't have a 15-minute. And then once it's done, you can just kill the container. So that would be the easiest one. Or another option that I've done is I actually, in this system, I do like a sync once a month where I get everything that came in from the month. That's part of what Chris talks about, like the backfilling. And that does take more than 15 minutes to run because the Stripe API is like really slow. It is. So what I did in that case is I put a timer in where it said, this is the last event ID that I processed. And then it creates a new event that spawns a new Lambda. And then when I call the Stripe API, it just starts calling the API from that event, if that makes sense.
That makes sense. Yeah.
Okay, so that's like a way to get around it.
So there's no like standard way that somebody has come up with. It's like just either do containers or do something like that.
I mean, honestly, I wasn't thinking containers when I did that. I would probably do it as a batch job. Well, I don't know, because I'd already written the code for the Lambda and it was easy to just put the event out if I didn't get out there.
I was also just gonna say, like, if you're consistently going to have to deal with cases where the runtime is longer than what's gonna fit in the Lambda's lifecycle, just don't use Lambda in the first place for that.
That's what I'm saying. Like, you'd be better to really run it in a container, right?
Yeah.
So what happened in that case is I already written it for Lambda and I didn't want to rewrite it. So I just figured something out. That happens in software. None of you've ever done that, have you?
Not once.
Not once. Okay. Just making sure. Okay. So I'm the bad guy here. All right. So I think that covers that. Alrighty. So as I mentioned, our company, we had some legacy applications which are written in PHP. So you can run PHP in Lambda if you like root canals. So we are on a journey towards serverless, right? So this is the architecture that we have now. We originally had our apps and our services, and these were the PHP, and they were just running on EC2 instances, but we had to have large enough ones to handle the scale that we needed for our peak hours. So what we did is we just got this elastic load balancer, and what it does now is it comes into Fargate. We packaged up our applications and then our backend services, put them in containers, and then said, hey, if a container gets more than this many requests, start a new container. And Fargate handles all of the routing and all of that. The clients just come into the elastic load balancer, admin.advicemedia.com, whatever it is. And then all of the scaling is handled here, and also the services. And the other entry point we have is we do have some APIs that we have open to our clients, but those are on a public IP address. So this API gateway just accesses Fargate here. And so what this has done is we've been able to move away from having EC2 instances. We've been able to move away from managing them. We've been able to move away from auto-scaling groups and worrying about all of that to really just worrying about our containers. And for me, because I'm responsible for doing everything, from end to end, it gives me more time to focus on my development work, okay? And then of course we've got, you like your classic 3-tier architecture, and then we have, caching layer, and we have the database layer. And really, in the journey towards serverless, we could do more in these other places, and we will, but we started that journey by just replacing our compute layer with a serverless format and putting in the API gateway, which will also handle the serverless towards the front-facing clients. So that's a bit of our journey. And again, I just want to say that I think most of us who are here, we're here because we want to code, right? I mean, maybe we have some people who really love infrastructure, I don't know what happened to them, but no, I'm just joking. I'm just joking. I mean, actually, it's really fascinating. I enjoy it myself. But just to reiterate, we want to code, we want to work on our applications, and we want to deliver to our product owners. progress. Because they don't care about if I updated the Linux kernel. They care about did the feature come out, did the bug get fixed, right? So by moving to this kind of architecture, I can spend more of my time working on the code, delivering product features, delivering value to my clients, worrying less about this, and also saving money on my compute and delivering faster. So with that, I thought I would just add that what you could do if you wanted to learn more. AWS has serverlessland.com. That's a great place to get started. There's all kind of articles and stuff you can read on there. If you want to dig into it a little bit more and actually build an application in serverless, AWS has this serverless workshop. It's free. You just sign up for it. It's self-paced workshop that you can go through and you build an application on a serverless framework from the ground up. And then another thing that that is an option for you is on May 24th, they're having a live, a 4-hour live serverless workshop. It's free. You just go to this here, you sign up for it. They'll have instructors, they have their serverless specialists. They'll explain the whole thing to you. You'll build an application with them. You can ask all of the questions that you want. And if you really want to learn it, take 4 hours out on the 24th of May and just get there and give it a try and see what you learn. And also think about it as a journey, like what we've done. We didn't just change everything to serverless in a day. We started doing Strike, so we did that using Lambda. We decided, hey, let's not rewrite all of our legacy applications. Let's just put them in a Docker container and put them on Fargate. And just kind of give it a try. And hey, I'm on a journey. I'm not an expert in. I'm not like the expert in all of this stuff. So if it's something you're interested in pursuing, come talk to me. I'm happy to talk to you about it. It's a journey we can go on together. And thank you for giving me your time.